Music. In this video we are going to see how we relate the concepts of mass, chemical quantity and quantity of particles, which are also related to what we saw in the previous video of calculating the molar mass of a particular substance. We are going to try to answer this instruction is that I want to determine the mass of a substance that is going to be carbon monoxide. Let us remember that the mass is expressed by the symbol with the letter m and that its unit is gram. I also want to determine the number of particles. The number of particles is represented with the capital letter N and the unit will be particles, but these particles could be molecules, they could be atoms, or they could be ions. What will depend on the substance? In this case, the substance is a molecular substance, carbon monoxide. Carbon therefore. Carbon monoxide contains molecules and therefore the molecules are going to be my answer to the number of particles. What do I have as data to give this answer? I have data that my sample has 2.5 moles. And therefore they are giving the value, or I am giving you the value of the chemical quantity that is symbolized with N and its unit is the mole. So I have the chemical quantity as data. Let's organize the information we have in a column that says what my data is and what my unknowns are. That my data is that the chemical quantity of carbon monoxide is equal to 2.5 moles. And I will also have two more data that are not in the letter of the exercise. I will have as data the molar mass of the carbon monoxide that, although the exercise does not tell me it, I can calculate it. And in this case it is the mass of carbon plus the mass of oxygen. Therefore it is 28 grams for each mole, and I will also have Avogadro's number as data, which tells me that 1 mole of any substance contains 6.02 times 10 to 23 particles that we already know that in this case they are molecules. Those are then my data. What are my unknowns? That is what I have to calculate. I have to calculate the mass of carbon monoxide. And I have to calculate the amount of carbon monoxide particles. As the first method we are going to use proportionality, that is, the rule of 3. And as the second method we are going to use equations. First I would suggest that we start by putting what data I have, then I am going to write that I know that 28 grams of carbon monoxide here are contained in what I call a mole of substance, and I also know that that mole of substance contains 6.02 times 10 to the 23rd molecules. And in this row of data I have everything to be able to determine the mass and the chemical quantity. How, considering these data as rules of 3, what am I going to do under the first row, which is the row of data? I am going to place my real data, not this. These are this information. I take it from the molar mass. here, and the I get from Avogadro's number from here. This entire row of data I get from these two. What did he add to my row of data? Below, I'm going to put the other data that I have, which in this case is 2.5 moles of carbon monoxide. Where do I go? To place under the mole unit I am not going to place it under grams, I am not going to place it under molecules, I am going to place it under moles, so I have 2.5 moles of carbon monoxide. What am I going to do now? Consider this data to make two rules of 3 and then, for example, if I consider this part of the data here in this box, I have a rule of 3 that tells me the following: that 28 grams of carbon monoxide contains 1 mole and therefore 2.5 moles of carbon monoxide will contain X number of grams I have. Already calculated the mass of carbon monoxide, and there are 70 grams that we have left to do. We have yet to calculate the amount of particles, and for that we are going to go to the other part of this data. I am going to delete I. I'm going to delete the previous signage so that it does not raise doubts. And then now I had left 1. Now I am going to stay with the other part of the information. I am going to stay with that 1 mole contains 6.02 times 10 to the 23rd molecule, and with that I am going to calculate the second unknown, so I know that 1 mole contains 6.02 times 10 to the 23rd molecule. And this is for any substance, so in 2.5 moles there will be X number of molecules. X will be equal to 2 and 5 moles times 6.02 times 10 to the 23rd molecule divided by 1 mole. Again, the repeating units that are moles cancel out, and the final unit is molecules. X gives 1.5 times 10 to the 24th molecule. And therefore, I have my second unknown, and now I know that it is 1.5 times 10 to 24 molecules. And here the entire exercise would be summarized. With 2 rules of 3, let's say that we solved the entire exercise. if we have to take into account that the most important thing is that you manage to identify this. If you manage to identify this ORB, the relationship between grams, moles and molecules that comes from the molar mass of the substance and Avogadro's constant, you can solve this exercise by rules of 3. Now we are going to solve the same exercise but based on the use of equations that we have to know. To be able to do it, we have to know the relationship between the molar mass, the chemical quantity, and the mass, which is that the molar mass of a substance is determined as its mass over the chemical quantity, and this would be, let's say, my first equation. And I must also know that the number of particles of a substance can be calculated as the number of moles, the chemical quantity times Avogadro's number, and this would be my second equation. With these two equations and the data I had previously, I will be able to calculate what you are asking me for, so I will return. Let's write the data that we already had for the first part. My data is that the chemical quantity of carbon monoxide is 2.5 moles. The other data I have is that the molar mass of carbon monoxide is 28 grams per mole. And for lastly, I know that Avogadro's number is 6.02 times 10 to the 23rd molecule per mole. So with this data and the two equations, I will be able to determine the mass and the number of particles, which are the two things they are asking me for. Well, let's go. So first, with the mass of the two equations, the only one that contains mass is the first one, so I start from that equation and substitute data. Instead of molar mass, I am going to put instead of molar mass, I am going to use the molar mass value, which is 28 grams. From molar mass 28 grams per mole, then I am going to substitute in that equation in this one, which is the first thing I calculate. I am going to substitute data molar mass 28 grams per mole. It will be equal to the mass I don't know. You can put X if you want. Divided the amount chemistry C 2.5 moles. Divided 2.5 moles. So now I only have to solve the 2.5 moles. Happens by multiplying the other member of the equality, so I have 28 grams per mole times 2.5 moles. It will be equal to the mass. Then the mass is going to be equal to 228 times 2.5 gives 70. Mol. In the mole divisor in the numerator I cancel them, and the unit I have left is grams. So I already calculated my first unknown because it gave me 70 grams. And now we go with the second thing I have to calculate is the number of particles and substitute it into that equation. The number of carbon monoxide particles is going to be equal to the chemical quantity 2.5 moles times Avogadro's number 6.02 times 10 to the 23 molecules for each mole. 2 with 5 times 6.02 times. Either of these two methods